Okay, so we continue with understanding how electromagnetic waves are produced. So second example is of this light right here. We see the visible light from this bulb, and the light emitted by this bulb is caused by the thermal motion. Let me write it here. Thermal motion that will accelerate the electrons in the hot filament of this bulb. And that's how we see the visible light. The light produces this. So again, the thermal motion is there inside this bulb, and that thermal motion accelerates the electrons that is there in this hot filament. And that is how this bulb produces the visible light. So now that we've saw two examples. The first one is the current uh, carrying conductor. When the current passes through the wire, due to the charge motion, the EM waves are produced in the wire. And the second example is of the bulb. Now, this was the direct effect, and another is called as inverse effect. So what is inverse effect? So for example, there is this wire and there is no current flowing through it, and if the EM wave strikes this wire, so when the EM waves, electromagnetic waves, strikes this wire, it will induce an AC current um, inside this wire. So again, the charges will start flowing this wire, and the frequency of that AC current that is flowing through this wire would be same as the frequency of the EM wave. Okay. So this is how the receiving antennas of, let's say, the radios or your television sets work. So EM waves come and they strike these antennas, and it induces the current through the wire. Okay. Okay, so here we see that the antenna, we are talking about the antenna where it is the radio reception antenna or the antenna used for the television. This antenna is most efficient when it is transmitting the electromagnetic waves or it is receiving an electromagnetic waves. Whether it antenna can act as a transmitter or it can act as a receiver. So its length of this antenna is basically how big in size this antenna can be, uh, depends on its decides its efficiency. So it's highly effective and highly efficient when the length of an antenna is of the order of the wavelength of the electromagnetic wave that it receives or it emits. So lambda, we know that is the wavelength. So if it is like 1 meter or say 10 meter or something like that, so the length, antenna length should be of this order, so that the antenna is highly efficient to receive or emit the EM wave. So you see now, this is the antenna right here for radio transmission or the reception. This is the antenna for TV reception. Okay, these are the receiving antenna I have shown here. So the wavelengths that these antennas are receiving are on the order of meter. Okay, so it's like they are used to receive, this is to receive the waves, which is order of the meter. Okay, so the waves used for TV transmission, for example, they have wavelength of about 1 meter, and this is also the size of a typical TV antenna that is used for reception. So for the TV transmission, okay, transmission again, the waves that are used for TV transmission, they have a wavelength of lambda is approximately 1 meter. So the television antenna, which is shown over here, they also have the length of 1 meter. Okay, so that's why there is efficient transmission and the reception.